Welcome to Module 2. In this module, we're going to talk about functions from an algebraic perspective, whereas in Module 1, we talked about them strictly from a graphical perspective. I have the first 5 functions we looked at in Module 1. And this time I've included the equation or the symbolic representation of these top 3. We have the linear function, the polynomial, which in this case is a quadratic, and a polynomial, which in this case is a cubic. So the domain of each of these functions is all real numbers. You can see it's minus infinity to infinity. But why? So when we looked at these functions graphically, we said because they're continuous. There's no breaks, there's no holes, there's no value of x that you can't put in this graph. Now if we look at the equations, let's think about what we're doing when we plug a number into this linear equation. I'm starting with some number x, I'm multiplying it by minus 3, and I'm subtracting 12. I'm going to get another real number, and there is absolutely no reason I can't subtract 12 from any number. There's no reason I can't multiply any number by minus 3. All real numbers x can be put into this equation. Now let's look at the quadratic. Same thing. I can always square any real number. And the square is always a positive number. That's why the graph is above the x-axis. Now let's look at the cubic. Again, I can cube any real number. I'm just multiplying it by itself 3 times. I can square that same number. I can multiply by these constants. There's nothing in this equation that would give me some weird result like dividing by 0. So this is why the polynomial has a domain of minus infinity to infinity.